This video is on solving quadratic equations using the quadratic formula. I am actually on example 4. I want to get this into standard form. I have an ax squared, which is positive, so I'm going to keep that. So I have a positive 2x squared. We need our x term, which is that 7x, which needs to be on the other side, so we have to subtract the 7x. Then we want our constant, which is on the correct side, so it's just plus 3 is equal to 0. Our a value is equal to a positive 2. Our b value is equal to a negative 7. And our c value is equal to a positive 3. Plugging it into the quadratic formula, I'm using the letter x because it's x. X equals negative parentheses negative 7 close parentheses plus or minus the square root of parentheses negative 7 parentheses squared minus 4 parentheses 2 parentheses 3 close parentheses, and this is all over 2 parentheses 2 close parentheses. So we have x equals a negative times negative 7 is positive 7 plus or minus the square root of something, which we're going to figure out in just a second. All over 2 times 2 is 4. So we're going to find our discriminant using our calculator. So it's parentheses, negative 7, parentheses squared, minus 4, parentheses 2, parentheses 3, close parentheses. It's the same thing that's written in the discriminant. This is equal to 25. 25 is a perfect square, so we know that our answers will have two real rational solutions, meaning we will not have a radical left over. We will separate them into two separate answers. So we have 7 plus or minus, we're still going to have over 4. The square root of 25 is 5. So now we solve this by combining our terms. We have x equals 7 plus 5 is 12. Divided by 4 is 3. Then we have x equals 7 minus 5 is 2. Divided by 4 is 1/2. So these are our two solutions, 3 and 1/2. X equals 3 and x equals 1/2. We had two real solutions and they were both rational. That means that we can separate them into two separate answers without any problems and any complaints about that. This next problem, again, we want to get into standard form. We have a positive x squared, and that's the only x squared term we have, so we want to keep that. So we have a positive x squared. We need our x term on the other side, so we have to subtract the 4x. We need our constant on the other side, means we have to add that 1 and equal it to 0. So our a value is equal to that positive 1. The b value is equal to the negative 4. And the c value is equal to a positive 1. In the quadratic formula, we do have x. We're going to use x equals negative parentheses negative 4 close parentheses plus or minus the square root of parentheses negative 4 close parentheses squared minus 4 parentheses 1 parentheses 1 parentheses all over 2 parentheses 1 close parentheses. Again, it's negative b plus or minus the square root of b squared minus 4a times c all over 2a. So we're going to have x equals negative times negative 4 is a positive 4 plus or minus the square root of something all over 2 times 1 is 2. So we want to figure out our discriminant, and that will tell us how many solutions we're going to have and what type. So again, our discriminant we're going to use in our calculator. Parentheses, negative 4 close parentheses squared minus 4 parentheses 1 close parentheses 1 close parentheses, and we get 12. 12 is not a perfect square, but it is positive. Therefore, we're going to have two real irrational, meaning we're going to have a radical left in our answer. So we're going to write our answer as one set, but we can explain it as two different answers. So this becomes, we have 4 plus or minus, and then we still have all over 2. We're going to simplify the square root of 12. 12 is going to be 4 times 3. So we know the square root of 4 is 2. We have the square root of 3 left over. So we need to separate these into two fractions to see if we can simplify. So we have 4 over 2 plus or minus 2 square root of 3 over 2. And again, the square root of 3 has to stay in our answer. So this will be 4 over 2 is 2 plus or minus. We're going to have the square root of 3 still, but it's 2 divided by 2 is 1. And then we have the square root of 3 because the square root of 3 will stay. This cannot simplify any further. So our final answer will be x equals 2 plus or minus, and then it's just 1 square root of 3, which is just the square root of 3. So our two solutions are actually 2 plus the square root of 3, and then 2 minus the square root of 3. Those are our two solutions, but we can write it as one answer because we still have a radical left inside of it, because it was an irrational number. So they were still real, there's no imaginary, and they are irrational because square root of 3 cannot simplify further. On this last example, we have the letter m, so our quadratic formula will actually be m equals this time. We need to get this in standard form. We want a positive a value. So we have a negative 6m squared and a negative 9m squared. What that means is we want a positive m squared. So if we add the 6 over, it would still be negative. But if we add the 9 over, it'll become a positive. So that means we want to move this side over to here. So we're going to add the 9m over here. Add 9m squared. So we're moving the right-hand side over. That also means we're going to add the 3 to the constant. So we're going to have a positive 3m squared, a positive 9m, and a negative 15 is equal to 0. Now it's in standard form, and your a value is positive. So a is equal to 3, b is equal to 9, and c is equal to 15. So this time on the quadratic formula, we're going to use m equals negative parentheses 9 close parentheses plus or minus the square root of parentheses 9 parentheses squared minus 4 parentheses 3 parentheses negative 15 close parentheses. All of this is over 2 parentheses 3 close parentheses. I did not put my negative up. You can kind of see that negative up there. I'm going to make it a little bit more noticeable. This is negative 15 because the c value is negative 15 from up here. We're going to simplify. So we have m equals negative times 9 is negative 9 plus or minus the square root of something. All over 2 times 3 is 6. So let's determine our discriminant using our calculator. I have parentheses 9 parentheses squared minus 4 parentheses 3 parentheses negative 15 close parentheses. And we get 261 is our discriminant. So let's see if that's a perfect square. Square root of 261 is not a perfect square. So therefore we will still have a radical left in our answer. So we have 261 as our discriminant. So let's see if we can simplify that. Do our arrow. This is negative 9 plus or minus and still all over 6. Let's see if square root of 261 can simplify. Okay, so 261 divided by, we're going to start with 15 squared, which is 225. Does not work. 261 divided by 14 squared. 261 divided by 13 squared. 261 divided by 12 squared. 261 divided by 11 squared. 10 squared. 9 squared. Sorry, 261 divided by 9 squared. 261 divided by 8 squared. 261 divided by 7 squared. 261 divided by 6 squared. 261 divided by 5 squared. 261 divided by 4 squared. 261 divided by 3 squared. So 3 squared does work. And since it was 261, I started with 225. That's not necessarily the smallest. So, the biggest number that I could have started with, because I could have gone bigger. So I'm going to put 9. Square root of 9 is 3. So we have 3 square root of, it was 29. Now I'm going to see if that square root of 29 can simplify further, just in case. So 29, I know 36 is too big, so I will start with 25. So 5 squared. 29 divided by 4 squared. 29 divided by 3 squared. 29 divided by 2 squared. And then 29 divided by 1 squared just stays the same. So actually this is as simplified as that radical can get. So it's still 2 real irrational. So we're going to separate the two fractions. Negative 9 over 6 plus or minus, we have 3 square root of 29 over 6. So negative 9 over 6 is negative 3 over 2 plus or minus, and then 3 over 6 is 1 over 2, and we keep that square root of 29. And because these already have the same denominator, we can put them back together. So our answer will be m equals, it's going to be all over 2. We're going to have negative 3 plus or minus. We're going to have, it's 1 square root of 29, which is just square root of 29. Then it's all over 2. So again, our two solutions are actually m equals negative 3 plus the square root of 29 all over 2. And then m equals negative 3 minus the square root of 29 all over 2. And this is, again, how you do the quadratic formula. The discriminant told us of, it was 261, told us we would have 2 real irrational, meaning we still have the square root symbol in our answer.